Hello students, today we are going to discuss the third numerical of slope deflection method. Question is written as a prismatic beam PQR of flexural rigidity EI equals to 1 into 10 to the power 4 kilonewton meter square is subjected to a moment of 240 kilonewton meter at Q as shown in the figure. Here a moment of 240 kilonewton meter in anti-clockwise direction is shown. Now we need to find the rotation at Q in radian up to 2 decimal places. Okay. Now we need to find the rotation of joint Q in radian. For finding the rotation at Q, we need to compute the fixed end moment, but the fixed end moment for QP and QR will be equals to 0 because no load is acting on the span QP as well as QR. Okay, as well as theta P is equals to theta R is equals to 0 due to fixed support at P and R. So theta P and theta R both will be equals to 0. Now we have to write here the slope deflection equation for QP and for QS. For QP it will be equals to fixed end moment at QP plus 2EI upon L 2 theta Q plus theta P. The value of theta P is 0 and we had not written here the delta term because delta is also 0 in this beam. So after putting all this value, that is L value as 5, 2 EI into 2 theta Q, theta P will be equals to 0. We will get MQP equals to 4 EI theta Q upon 5. Similarly, we can determine MQR, which will be equals to fixed end moment at QR plus 2 EI upon L 2 theta Q plus theta R. Here the value of theta R is 0 due to fixed support at R and delta value is already 0. Now after putting all the value, we will get MQR equals to EI theta Q. Now we need to apply the joint equilibrium condition at Q, which will be equals to MQP plus MQR will be equals to minus 240 because anti-clockwise moment of 240 kilonewton meter is acting at joint Q. Now after putting the value of MQP as 4 by 5 EI theta Q plus MQR value, that is EI theta Q, which will be equals to minus 240, we will get theta Q as minus 0.013 radian. Now here the negative sign shows that the rotation of Q is in anti-clockwise direction. So we had just written theta Q as 0.013 radian in the anti-clockwise direction. So in this way we had computed the rotation of joint Q, that is 0.013 radian in the anti-clockwise direction. Student, we had completely solved this numerical. Thank you very much.